Alright, hello viewers, you're welcome to my YouTube channel Mathematics Made Easy. So in today's video, we are solving this problem. We are learning product rule. Okay, this is another section of the differential calculus. So my previous video, I've explained how to differentiate some functions with the first principle. So in today's video, we'll be looking into another branch of it, which is the product rule. Okay, that is how to differentiate product of two functions. So you can see this is f of x and g of x product. F of x is a function, g of x is also a product, is also a function. Okay, they are product. How can we differentiate it? Okay, that's what we'll be doing in today's video. All right, so if you are new to this channel, please don't forget to subscribe, like, comment, and then also share. All right, guys, so thank you. Let's move on to the solution. All right, so solution, I'm gonna explain how to do this. All right, and then I'm gonna give you guys some example on this particular topic. Okay, guys, so the y dx, or you call it y prime of x. Okay, so the y dx, or you call it y prime of x, so which is equal to, all right, so this is what you're gonna do. You're gonna differentiate f of x, and then you are going to fix what's it called, g of x. Okay, so if you differentiate f of x, you're gonna have f prime of x. Okay, then if you fixed g of x, so you're gonna multiply the derivative of f of x by g of x. Okay, so we have g of x, then plus you differentiate g of x, and you are going to fix what, f of x. Okay, so if you differentiate g of x, you're going to have g prime of x. Okay, then if you fixed this, you multiply the derivative by f of x, so you have this, and that's how you differentiate this kind of function. All right, guys, let's do this example so that we can know how to deal with this kind of function anytime we come across it. All right, so example 1. Now look at this function. We have y is equal to x, then e raised to the power of x. Okay, so I want to differentiate this. So e raised to the power of x is exponential x. All right, so how can we differentiate this kind of function? You can see x is a function, e raised to the power of x also is another function, product of two functions. So how can we differentiate this? Then you apply this particular rule, which is the product rule. All right, so we're going to have the y over the x is equal to, now the first thing is to differentiate x, and then you fix the what, you fix e raised to the power of x. All right, so if you differentiate x, you're going to have 1. All right, don't forget that. Okay, if you differentiate x, you're going to have 1. So 1 multiplied by e raised to the power of x, so that's going to give us e raised to the power of x. Plus the next thing you're going to do is to differentiate e raised to the power of x. Then if you differentiate e raised to the power of x, what we're going to have will be e raised to the power of x. The funniest part about this exponential x is that the integral and the derivative is constant, it's the same, which is e raised to the power of x. All right, so if you integrate e raised to the power of x, you have e raised to the power of x. If you differentiate it, you have e raised to the power of x. All right, so then you multiply by what, x. So we're going to have x e raised to the power of x. So if you like, you can factor out e raised to the power of x. So factor out e raised to the power of x, we're going to have e raised to the power of x, then into bracket 1 plus x, and then, so that's the derivative of this particular function right here, which is x e raised to the power of x. All right, so let's do two more solutions, two more examples to back this up. All right, so example 2. So let's say we have this function y is equal to x raised to the power of 3 sine x. All right, so how can we differentiate this function? Yeah, using the same method. Okay, so we have the y dx, I said the y dx would be what, f prime of x multiplied by g of x. All right, then plus g prime of x, then multiplied by f of x. Okay, so that's the product rule. So your f of x is x raised to the power of 3. So we say f of x is x raised to the power of 3. Then f prime of x, that is if you differentiate x raised to the power of 3, this is raised to the power of 3. You can use the first principle or use the normal formula for the differentiation. Okay, so this will be 3 multiplied by x, then raised to the power of 3 minus 1. Then this is going to give us 3x raised to the power of 2. All right, then g of x, which is sine x. So we have g of x, which is equal to sine x. All right, then if you differentiate this, you have g prime of x. So if you differentiate sine x, you're going to have cos x. So beautiful. Just input all the results into this formula, then we're going to have dy over dx, which is equal to, so f prime of x, which is 3x squared, all right, so and then g of x, which is sine x, okay, then plus g prime of x, which is cos x, then multiply by f of x, which is x raised to the power of 3. Then this is going to give us 3x squared sine x, okay, then plus x raised to the power of 3 cos x, and that is the answer to that problem. Okay guys, so let's do the last example, then give you guys class so we can try. So here's the last example. Let me use another marker for that. All right, so we have y is equal to, so let's just say sine x, okay, sine x tan x. So why can't we differentiate this function? All right, this is very simple using the same method. So we say dy over dx, okay, which is equal to f prime of x multiplied by g of x, okay, then plus g prime of x multiplied by f of x. All right, so what is your f of x? So my f of x here is sine x, and then my g of x here is tan x. All right, yeah, so f prime of x, so if you differentiate sine x, don't forget you're going to have cos x. Then if you differentiate cos tan x, you're going to have sec square x. All right, okay, so let's input all these results into this formula right here. So we're going to have dy over dx, which is equal to f prime of x, which is cos x, then multiply by g of x, which is tan x, okay, then plus g prime of x, which is sec square x, then f of x, which is sin x, okay. Then this is going to give us, you can write tan x as sin x over cos x. So we have cos x, then into bracket sin x over cos x, okay, then plus sec square x is 1 over cos square x, because sec x is 1 over cos x, so sec square x will be 1 over cos square x, then multiply by sin x. All right, what do you notice? Cos x, we cancel cos x. So what we have now will be, so let's just continue right here. So what you have now will be sine x, okay? Then plus, 1 over cos square x can be written as 1 over cos x multiplied by 1 over cos x multiplied by sine x. All right, so we can write this as sine x. Oh, sorry, this space is very small for that. Let's just move to the next page. Let's move to the next page so that we can have enough space to write. So what you're going to have will be sine x, okay, plus 1 over cos square x sine x. This is where we stopped, okay, and so we can rewrite this as sine x plus sine x over cos x, okay, then multiply by 1 over cos x. Don't forget cos x times cos x will give us cos square x, and then sin x over cos x will give us what? That should give us tan x. So we have sin x, okay, plus tan x, then 1 over cos x will give us sec x, and that's the answer to that problem. And then if you don't want to solve this using this way, the function given to us is y is equal to sin x tan x. So you can just write this as y is equal to sin x, then plus, tan x will give us what? Tan x will give us sin x over cos x, and then sin x then sin x will give us sin square x over cos x. Then yeah, you're gonna have to use the quotient rule, but I haven't teach you how to use quotient rule, so that will be in the next video. All right, so I'm gonna teach you how to use quotient rule to differentiate some functions. All right, so if you like this kind of video, please don't forget to subscribe, like, comment, and also share. See you next time. Thanks for watching. Bye.